Here we have a poorly drawn circle. This represents a circle. Center is at the origin. Radius of the circle is A. The coordinate of this vertical line, I'm going to say, is just plain old X. It could be any X. Okay. Now, I want you to draw that picture. I want you to draw a picture just as it is. Then I want you to shade in or just make the line solid. When you draw the picture, there should be a dotted line, but make a solid line segment for the part of this vertical line that lies inside the circle. Stop and do this. Now you've stopped and done it, I hope. The part of the circle that I specified, the part that's inside, the part of the vertical line that's inside the circle is here. Okay, so my question is, what's the y coordinate here? And what's the y coordinate here? So again, stop and work that out. Don't wait for me to tell you. You won't learn anything that way. You got to do the work. Okay? Okay, well, you've had a chance to stop and, implicitly complete the diagram so that you can show how you got the picture. So don't just quote some formula you saw, show the geometry of it. If you haven't done that, stop and do it. Okay, so the geometry of the thing is fairly straightforward. We can complete a right triangle here, and we can complete another right triangle down here. We know two legs of the triangle. If we just take this vertical triangle, this leg is X. This leg is, well, what's the vertical side of this triangle? And how far is it from here to here? I've already given you too much of a hint. I should have stopped at this picture and told you to go ahead and work it out. But here's the right triangle and hint. This leg is X. You should really incorporate that, internalize that, if it's not obvious to you. Okay, well, if you've done that, then you know that the hypotenuse is just a radius of the circle, so that's A. And then by the Pythagorean theorem, what's this? Now you should write that down. Okay, don't wait for me to write it down, write it down. And if you can't write it down instantly, you really need to be drawing more pictures and using basic high school geometry and trigonometry more extensively so it really gets internalized. Okay, well, I'm going to give you the answer now. Hopefully, you've written it down. There it is. Why? It's because this side plus this side squared plus this side squared equals this side squared. That is, square of this leg plus the square of this leg equals hypotenuse. So if this is unknown, x squared plus the unknown equals a squared, and you solve that for the unknown, and you get x squared equals a squared minus, the unknown is this a squared minus x squared. So the square root of that is this. Anyhow, everybody should know that. Now, my question is, then, how would you describe all the y coordinates from down here to up here, including, let's say, the y coordinate on the circle, which you're going to need? Okay. So, how would you describe the y coordinates in the circle by inequalities? Okay. Make sure you stopped and done this. We can say that, well, here y equals the square root of a squared minus x squared. Here y equals the square root of a squared minus x squared. But here it's, of course, negative. Okay, so how far is it from here to here? Well, to get from here to here, you got to go this far. To get from here to here, you got to go this far. So it's going to be twice that far. Okay, so there's the inequality on y. Now, x could be any number. Okay. What are the limits on x? Y is limited because we've specified some arbitrary value of x. And these limits on y change when x changes. If we chose an x over here, y would go from here to here. It'd be still square root of a squared minus x squared if you use x as the variable. You have a bunch of different x values for the variable. Okay. How do you describe the disk? Write that down. Start with what are the limits on x? I'll give you a hint. The only limits on x is the vertical line through x has to touch the circle. Usually in 2 points, just 1 point here at the ends. Okay, so what's your answer? Hopefully, again, you've written it down. It'd be obvious. If the radius is a, then from here to here, distance is a, that puts x at negative a. From here to here, x, again, you have a distance a. That makes this point, that gives this point the x coordinate a. So there it is. So the disk is described by these two inequalities. Imagine x running from negative a to a, and for any given x, y runs from the negative square root of a squared minus x squared to the positive square root of a squared minus x squared. If you wanted to integrate something on the disk, let's say you wanted to integrate the values of f of x, y. What would the integral of f of x, y over the disk be? Write down the integral. Okay, answer. X goes from negative a to a. So you're integrating from negative a to a with respect to x. For any given x, you've got to integrate from negative square root of a squared minus x squared to square root of a squared minus x squared. Didn't leave myself room. Got to have a dy in there. But again, what's your order of integration? Well, you've got to integrate y first. So that's dy and then dx. Now, when you integrate f of x, y with respect to y, then when you find an antiderivative with respect to y, the integral is just going to be the value of the antiderivative when y equals this, subtracted from the value when y equals this. In other words, it's going to be f of, well, it's going to be the antiderivative at negative square root of a squared minus x squared, subtracted from the antiderivative at a squared minus x squared. That's going to give you x's in your expression. You already have x's because there's an explicit x dependence but now the y dependence has been changed to the value of y in the antiderivative function. Again, the value here subtracted from the value here. You do not want to write square root of x squared minus a squared. It's a squared minus x squared. You certainly don't want to write what I just wrote. Then the integral from negative a to a of f of x y dy dx. You could do this integral. Sorry, that should be in the order of dx dy. I mean, it shouldn't be even written this way, but these are the limits on x. You'd have to integrate x first. Okay, so if you integrate x first, you're going to substitute negative and a for all the x's in the antiderivative. Not going to have any x's left. Then you integrate with respect to y, and you're going to substitute negative square root of a squared minus x squared and the square root of a squared minus x squared for y. And now you're going to have x's again. You're not going to get an answer. Okay, so you don't do this. I've seen this on reading some recent assignments. This sort of thing, not the specific thing. Okay. Well, hopefully you've digested that. I could just as well specify a y value. I could say, now, same dimensions and everything. I'm not going to take the time to do all that. Y could go from negative a to a. Then you'd have to figure out where the corresponding line segment within the circle lies. And you're going to find out that you get negative square root of a squared minus x squared less than or equal to a squared minus y squared less than or equal to x less than or equal to the square root of a squared minus y squared. Because, of course, you have the same triangles. It's just that in this case, your hypotenuse is a, in this leg is y, so this leg has to be square root of y squared minus a squared. That would be this leg here. Okay, you need to think that through. Now, say that they have the function y equals 2x squared. Okay. If you specify a value of y then can you find the length of the segment within the parabola? Let's just say here y equals h up at the top. Okay, so we want to find the area within this parabola. If you have a value of y, then what are the limits on this line segment? What are the x coordinates of this point and this point? Stop and do that. Okay. Well, here's your x coordinate. X equals what? Well, Again, figure it out. But here we go. Here you figured it out. Since y equals x squared and y is greater than 0, x equals plus or minus the square root of y. Now, since x is positive on this side, we're going to choose the positive square root of y. And of course, we have an x over here. It's equal to the negative square root of y. So can you write the inequalities that describe this region using calculations we've done here? Again, stop and do this. But here we go. Okay. Well, y is going to go from 0 to h. Uh-oh. I made a mistake, and hopefully you didn't. Since y equals 2x squared, x equals plus or minus the square root of y over 2. Okay, I wrote down y equals x squared, accidentally forgetting that I put a 2 here. There it is. Okay, in any case, y is going to go from 0 to h. Then for given y, x is going to go from negative square root of y over 2 to the square root of y over 2. So what's the integral for f of xy over this region? Hopefully you've written that down, thought about it, done the work to think through it. The integral is going to go from 0 to h with respect to y. I'm leaving myself plenty of room in here, I hope. And then it goes from, okay, of course you can't see any of that. There's what you should have gotten for the limits. Now we're writing down the integral. Y goes from 0 to h. We're going to integrate from 0 to h with respect to y, and from negative square root of y over 2, the square root of y over 2 with respect to x. Okay, and it's fy, f of xy with respect to x, then with respect to y. You see a pattern here. Right now we have fixed limits on one of our variables. And then we're inside the region when the other variable is between some value here and some value here in both cases. We need to go through and think through all the geometry of this situation. Now I'm going to take it just a step further. We have a circle of radius A. Center point is at y equals h. And x equals k. That is, this is the point hk. Now, if I draw a vertical line through here, what are the limits on the values of y? This vertical line has coordinate x. Well, hopefully the first thing you did was you drew two triangles that are going to give you important information. And you're going to find then that the vertical leg of each triangle is the square root of a squared minus x squared. Is that right? Well, it might be a little bit confusing, but yeah. This isn't quite right. Okay. Put x coordinate x here. Radius is a. The question is, let me stop a minute because I think I'm confusing it. Okay, now this isn't right and this isn't right because this leg here is not x. So if you wrote this down by rote, you didn't think through exactly the question of what is this leg. Okay, this leg has length equal to, trying to sort my chalk out here. Yeah, we will use yellow here. Equal to this distance here. And what's this distance here? This distance here is magnitude of x minus h. So if we carelessly do square root of a squared minus x squared, we're going to get most likely a pretty ridiculous answer. It's very conceivable that x could be a lot bigger than a, and we get a negative under the radical. I mean, the x-squared, you don't know where the origin is. The origin's way over there, then x is a bigger positive number than a. If the origin is way over there, x is a negative number whose square is still bigger than a squared. Okay, so when we do this, we want to avoid that little pitfall. And then I'm going to show you algebraically. Okay, I apologize. Traditionally, we use h for x and k for y. And when I drew this line, I'm thinking the x direction. So I wrote down x. And I wrote down x equals h because h goes with x. Okay. The triangle has dimensions, magnitude of x minus h here, and a here. It follows that this side is the square root of a squared minus the square of x minus h. That h is not coming out right, but there it is. Okay. Now, when you square the magnitude of x minus h, it doesn't matter whether x minus h is positive or negative. You're going to get the square of just plain old x minus h because that's always positive. it's very helpful if you start with the equation. So do this algebraically. So let's move to figuring something like this out as the equation. Okay, so what's the equation of the circle? Well, this is just a fundamental, really pre-calculus question. Okay, the circle has, well, write down the equation of this circle. Okay, now let's see if you got it. The equation of the circle is x minus h squared plus y minus k squared equals a squared. It's just the x squared plus y squared equals a squared circle, but we've horizontally shifted at h units and vertically shifted at k units, which means that we're going to use x minus h and y minus k instead of x and y. So now my question is, what are the limits on y? Now, there are two ways to see the limits on y. See if you can write them out one way or the other. One way, you just use a picture. Another way, you can use the equation. And we're going to do it both ways. Okay, given x, limits on y are what? Well, y equals k at the center. And then we're square root of a squared minus quantity x minus h squared units below that. So x minus h not h minus x. If we include the boundary, we can use less than or equal to y, which is less than or equal to k plus the square root of a squared minus x minus h squared. And we get that directly from the picture. Y is k up here. We go this much, this far higher, and we get k plus that square root. If we go that square root lower, then y equals k, we get k minus square root. Okay, now what are the limits on x? See if you can write them out. Okay, again from the picture, x equals h here. We can move a units to the right or left. A units to the left of x, of h is h minus a less than or equal to x less than or equal to h plus a. So if you have a good picture, you don't need to do a whole lot of algebra. Now, what if you don't have a good picture? What if you really just work better with the algebra? I tend to think that for most people, the picture is easier, but you've got to be able to do the algebra, because what if you have some equation that you just can't accurately graph and doesn't have a geometry that makes things simple, okay? Then what you have to do is use the equation, okay? So see how you would go about using that equation. Write it down. Okay, now here's the logic. You specified a value of x and you want to know what the limits on y are. If you have the equation, you can solve that equation for y. So please solve that equation for y. Okay, hopefully you've solved it, written it out, and you understand how to solve it. But not everybody is really that good at solving equations. Some people are much better at the geometry than solving equations. Now you have to be able to solve equations. So let's go ahead and solve this one for y. Well, it's pretty obvious that I could subtract x minus h from both sides, x minus h squared from both sides. We get y minus k squared equals a squared minus quantity x minus h squared. So that, what's the next step? Well, y minus k equals plus or minus square root of a squared minus quantity x minus h squared. So then you get y equals, add k to both sides. We could write the solution as k plus or minus the square root of a squared minus quantity x minus h squared. Now, this expression agrees with this side and with this side. K plus the square root on the right, k minus the square root on the left. Those are your limits on y. Does that tell you what the limits on x are? Now, the limits on x are pretty obvious from the picture, but if you're not using the picture, how does the equation give you those limits? See if you can answer the question. Okay. Y is a real number if and only if a squared minus the quantity x minus h squared is greater than or equal to 0. So x minus h squared, and I said it right, I did write it correctly, has to be less than or equal to a squared. Now, why did I reverse the inequality? Because I did two steps at once. I'm running out of board space. Okay. Well, if you subtract a from both sides, you get a negative a squared over here and a negative quantity x minus h squared here. If you multiply both sides by -1 or divide both sides by -1, that's going to make the signs positive. But when you divide by a negative, you got to reverse the inequality. And of course, you got to remember these things. Okay. That's something you knew in pre-calculus in algebra class. And maybe you still know it because maybe you've used it recently. I'm a little worried here. I'm going to prop this edge of the board up a little bit. Make sure you can see that, but now you probably can't see what's at the top. Okay, anyhow, you get quantity square root of x, you get x minus h squared less than or equal to a squared. So I'm going to bring that expression up here. Make sure I don't put it too high. X minus h squared is less than or equal to a squared. Means negative x minus h is less than or equal to a, which is less than or equal to x minus h. And if you then I'm not sure I like the way I wrote that down. Because I can't simply add h to both sides. Explain the algebra a little further. So that's going to be a little less clear. What this means is, and I don't like to bring absolute values into it, but you really need to know this. It means the absolute value of this side is less than or equal to, the absolute value of the square root of this side is less than or equal to the absolute value of the square root of this side. And that comes out with pretty much the same thing I was going to say, which is that negative a is less than or equal to x minus h less than or equal to a. And now I add h to both sides, I get negative a plus h less than or equal to x less than or equal to a plus h. And what I started to write down there was incorrect. This says the same thing as this, doesn't it? Of course, it's negative a plus h is h minus a, and a plus h is h plus a. And you probably can't see what's up at the top there. I'm not sure you can even see it now. The inequalities here were h minus a less than or equal to x less than or equal to h plus a. Because x equals h here, if you add a to that, you get h plus a. X equals h here, if you go to the left, subtracting a, you get h minus a. So x is between h minus a and h plus a. To use the equations is a little more involved, but you got to have the algebra to do that. So we solve the equation of the circle, which you should understand. Okay. And we solve it for y. Having solved it for y, we obtain a solution here. It gives us the same thing that our geometric reasoning gave us about the limits. And then how do we determine what the limits on y are? Y has to be a real number. And the only way y is a real number is if the square root here is a real number. If the a squared minus h squared is negative, it's not going to be a real number. You've got to get a square root of a negative. So you got a squared minus quantity x minus h squared, et cetera. And we get this inequality, which we then bring up here, translate to an absolute value inequality, which is totally equivalent, and solve that. And we get the limits. You understand why I advocate the geometric approach, being able to draw pictures, but sometimes you do need to be able to do the algebra. Now the upshot of this is then that we wanted to integrate f of xy over this region. We would have x going from h minus a to h plus a, and y would go from apologize for that, okay. Y would go from k minus the square root of a squared minus the quantity x minus h squared, k plus the square root of a squared minus the quantity x minus h squared. And we'd be integrating f of xy. Limits here are on x. That's an inequality for y. So we integrate with y first, and then with respect to x. Again, when we integrate, we get an antiderivative of f, assuming we get one, get an antiderivative of f with respect to y, holding x constant, everything. Then these two expressions are going to replace the y value. Okay, so we're going to have just x's when we integrate with respect to x between definite limits. I want to emphasize that understanding Because again, it's not clear that everybody totally understands that whole idea. Okay. So that's just a little bit about how you set up integrals, but without doing all the partitioning. Now you should also be able to do the partitioning. Understand that a delta y by delta x interval. Well, I need to draw a picture. It's going to have a sample point xi, yj. And you have to know how the y's change with respect to x and so forth. Okay, and that's pretty vague, but the goal here is just be sure you understand this process.